Today, we will be talking about data visualization in R, more specifically in ggplot. We will learn how to turn your boring, basic graphs into plots that are visually appealing and look ready for publication. Fortunately, we don't need a lot of R for this tutorial. We only need to know the very basics, such as using functions and also manipulating data frames. And in terms of libraries, we only need one library, which is called tidyverse. And if you don't have this already installed, you can install it by going into your console and saying install.packages and then in quotations tidyverse. But I won't be running that since I already have it installed. And we can load in this library and get started with the tutorial. So in order to get started, let's first load in our dataset. Let's store it in a variable called movies, and let's use the read.csv function to load in the file called movies.csv, and this file will be provided to you guys in the description so you can follow along. So let's load this in, and let's double click on this environment variable to look at the dataset. So this data is from IMDb, and it contains many different columns, such as the name of the movie, what year it was made in, its IMDb score, how many people voted on it, which country it's from, the budget of the movie, and its gross revenue. And basically, these are the main columns we will be using for our plotting moving on. So in order to create our first plot, the very first function we need is called ggplot. And let's just run this function by itself. And we can see that this creates a blank plot. And this is the canvas upon which we will be plotting. So in order to create our first basic plot, we need three things. We need the dataset, we need a mapping argument, and then we need the geometry. So the dataset's pretty self-explanatory, and we can specify the dataset in ggplot using the data argument, and then write in our movies variable, which is where we stored our data. Or we can also just remove the data argument, as the first variable inputted into ggplot will always be assumed to be the dataset. So the next thing we need is the mapping argument. And again, this can either be explicitly stated or this can also be removed, as the second argument will always be assumed to be mapping. And the only thing we need to input here is which columns will be the x variable and which columns will be the y variables. So in order to do this, we need another function called AES. And this stands for aesthetics, and we will be talking a lot more about this function later on. However, for now, let's just say x is equal to, let's say, the budget of the movie. Let's say y is equal to the gross revenue. So let's run this function, and we see that we have our axes now with labels and variables, but we still don't have our data points. And for that, we need the final thing, which is the geometry. And in order to add the geometry, we need to create a layer, as it's not inputted in the ggplot function, but rather outside of it. And in order to create a layer, all we need to do is add a plus sign and press enter. And here we can write geom, which stands for geometry, underscore. And as you can see, ggplot will recommend a lot of different geometries for you. But for now, let's try geom point, which is ggplot's scatter plot. And we can run this function, and we can see that this created our basic scatter plot. ggplot has a lot more geometries though. So we can add more layers by using the plus sign, and then we can add another layer on top of the scatter plot. Let's say geom line, which will add a line graph through all of the points. As we can see, now we also have a line graph on top, and we can add even more layers on top. So let's try geom smooth, which is a best fit line used for data visualization purposes. And as we can see here, this created a blue best fit line. However, this looks a little messy, so for now, let's get rid of geom line. And let's also get rid of this gray standard error in geom smooth. And this is what our plot looks like now. The first part of any plot customization should be adding in labels and titles. So in order to do this, we only need one ggplot function, which is added on as a layer, just like the geometries. So we can say plus, and then enter, and the function is called labs. And in order to add a plot title, all we need to do is say title is equal to, and let's call this plot budget versus revenue. And then we can also add a subtitle for this plot. And let's see what that looks like. So we can see that the title showed up right here and the subtitle showed up underneath it. Now, these plots already have X and Y axis labels that are the names of the columns that we use to make this data. However, if we wanted to customize this, we can also do that within the labs function by saying X is equal to movie budget in USD and Y is equal to gross revenue also in USD. And let's see what that looks like. So we can see that the axis labels are now changed. And with the labs function, we can add even more customization. For example, we can add a caption that says where the data is from. So let's say the source of the data is IMDb. And we can see that that showed up right in this corner. Let's just say we wanted this graph to show even more information than it already does. For example, what if we wanted the color of each of these points to represent the genre of the movie? We can actually do that very easily in ggplot. To select the color, all we need to do is say color is equal to red, for example. However, what this does is it changes the color of all of the points to red. But if we want to select the color by genre, this is when the AES function comes in handy again. What the AES function allows us to do is it allows us to map color to a certain variable from the movie's dataset. For example, we can map the color variable to genre. And as we can see, the color of each of these points now represents what genre they are. And conveniently, ggplot also automatically makes a legend for us. However, the plot looks a little bit crowded right now. So what if we wanted to highlight just one of the genres? So let's say we wanted to highlight action, for example. We can do that easily as well, but we need to do some very basic data manipulation. So we need to add a column called, let's call it if action. And we need this column to represent whether or not a movie is an action movie. So we can do that by saying movies genre equal to action. Now let's make this column and let's look at it. So this is just a true and false column, which says true when a movie is an action movie and false when it's not. And now all we need to do is, instead of selecting by genre, we need to select color by the if action column. And now the color of our points represents whether or not a movie is an action movie. Furthermore, we can even select quantitative variables here. So let's choose color by the IMDb score, for example. And when we use a quantitative variable, instead of a discrete variable, we can see that ggplot automatically creates a color scale to represent the IMDb scores. So at this point, I'm sure you guys are wondering how to customize the color scales of this plot. And we do have a way of doing that as well. And to demonstrate that, let's just go back to if action. And in order to customize the color of this plot, let's add another layer. And that layer will use a function called scale color manual, because we want to manually select the colors. The first argument that we're going to put in here is going to be called values, which will just be a vector of the colors we want on here. So let's say black for false, and let's say red for true. And let's add another value argument called name, and this will be the name of our legend. And let's call it is it action. And then let's add labels as well, and these will be the labels for false and true. We can customize those. And let's say no for false, and well, we need to make this a vector actually. Let's say no for false, and let's say yes for true. And then let's just connect everything by adding a plus sign here. And as we can see, the colors of our plot have changed. And now this blue line stands out a little bit, so let's just change the color of that as well. And we can come down to Geom Smooth here, and we can select color for this. Let's make it black. And now we can see our plot looks a lot better. Also, if you want to create a purely black and white plot and not use any color, but still highlight different genres, you can do that by using shape instead of color. And what this does is it gives action movies a different shape, and movies that aren't action different shape. But for now, let's go back to using color. Themes are where most of the customization of ggplot comes in. Themes are used to customize any non-data related components of the plot. So let's look at the documentation to see some examples of the components we can customize using theme. So as you can see here, there is a long list of components we can customize using this function. So how do we go about actually creating our own theme? All we need to do is create an additional layer to our plot and call the function theme. And then we can select any of the components that we want to customize and then show how we want to customize them. However, this can be a little complicated for beginners, so we would recommend using some of the built-in themes that ggplot comes with, such as theme BW is a personal favorite of mine. And we can see that the plot already looks a lot different. Additionally, if you would like to have access to even more themes, you can download the package ggthemes, and this will give you access to even more themes. So we can look at a couple examples. 538 is a really good one. And another favorite of mine is the theme clean. Once we've selected a theme that we like, we can add our own customizations to this theme by adding a custom theme layer. Just make sure that the custom theme layer comes after the pre-built theme. And we can use this layer to change anything that we didn't like about the theme we selected. For example, what if we wanted our plot title to be a little bit bigger? All we need to do is say plot.title and select what type of element this is. So this is a text element. So say element underscore text. And select what type of change we want. So we want the size to be bigger. And as we can see, the size of the plot title got a lot bigger. We can do these types of changes to many different elements. So let's change the subtitle a little bit. This is also a text element. So let's say we want the subtitles to be in italic. We can even change multiple things at once. So let's select the axis title this time. And again, this is also a text element. And let's make the axis titles bold. And let's also change their size to 12. Now the axis text looks a little small, so let's fix that as well. And finally, let's put the legend position on the bottom. As we can see, our plot looks a lot better now, and we've added a pre-built theme with our own customizations on top. Now let's look at what the final plot looks like.
Boom shakalaka.
Doesn't that look great? Now let's apply what we've learned to a tSNE analysis on gene expression data. And this data is provided to you guys, and I would encourage you to create your own plots and do your own customizations. Here's an example of what we've done. So like we talked about, we've started off by using ggplot and selecting our dataset, our mappings, and our geometries. And then we labeled our title and our axes, created a custom color scale, and then did our theme customizations. We did some things that we haven't touched on, such as aspect ratio, and then we also created a box around the legend. So let's look at what the final plot looks like.
Boom shakalaka.
There's plenty more things we can do with ggplot. I have given you guys a basic rundown on plot customization, and I would encourage you to download the datasets and experiment as much as possible. Since the more you experiment, the more you understand your own preferences for data visualization. Thank you for listening.